Now that you have been exposed to all of our parent graphs we're going to talk about moving them from their original position. So here are some basics. I can go up if I add on the outside, down if I subtract on the outside. The horizontal moves are different. If I subtract on the inside, I go right, and if I add on the inside, I go left. One way to remember this is IHOP. And that stands for inside, horizontal, and I think it was, oh, yeah, that's right, inside, horizontal, opposite. So I always know my inside operations are horizontal changes, and they're opposite of what I'm thinking they would do. I would think a subtraction goes left, but it actually goes right. Okay, when a question asks you to compare, it could mean two different things. It could mean graph the new graph, or just tell the movements. We'll do both. For this one, we're subtracting on the outside, versus this one we're subtracting on the inside. So if I'm on the outside, I'm going up or down, and in this case, I'm going to be going down 1. My parent graph of x cubed looks like this, these 3 points known. My new graph is everything is going to be moved down. I still have my 3 points all in a row. The entire graph is shifted down. If it's a move on the inside, now I'm talking about opposite, subtraction, so that's going to go right. So my middle point is going to be moved over to the right one, and the rest fall in line. This one has 2 moves. I've got an inside move here. That's going to go left 2. Outside, that's going to go up 1. So if I follow my middle dot from the middle, I'm going to go left 2, up 1. There's my middle dot. Everything else stays in proportion. Over 1, up 1, down 1, left 1. All came from the parent graph of x cubed. What is this equation? First, we have to identify what's its parent graph. It's a parabola, so my parent graph is f of x equals x squared. Now what happened to it? Normally my parabola starts at 0, 0. It's obviously been moved left 2 and down 1. Left 2, that's going to be an inside change, so x plus 2 on the inside. Down 1 is going to be a minus 1 on the outside. And let's see, that's 0, 0. That would be 0, 0. And then we would have 1, 1. And then we would want to check 2, 4. Yeah, that's crossing right there. So everything else is in proportion. There's no stretches or shrinking. Negative on the outside is going to mean a reflection over the x-axis. Negative on the inside is a reflection over the y-axis. So if I take these graphs, we need to know that the parent graph looks like this. Points at 0, 0 and 1, 1. And you really can't figure out another one until you get to 4. 3, 4. The square root of 4 is 2, so that one's up there at 2. So there's my parent graph. If I have to flip it over the x-axis, which is what that is on the outside, it's going to be going down here, 0, 0, 1, negative 1, and 4, negative 2. Negative on the inside means I'm going to flip it over the y-axis. Move that over a little bit. Take my parent graph, flip it over here. So now I'm still at 0, 0, negative 1, 1, and negative 4, 2. Now I've got 2 changes on this one. I've got a negative on the outside, so I'm going to reflect it over the x-axis like the first problem. but I've got a plus 2 on the inside, which means left 2. So I'm going to we've got the flipped over version over here. So I'm going to take that graph and go left 2 with it. So here's my graph. Instead of being at 0, 0, I'm going to be at negative 2, 0. Instead of being at 1, negative 1, I'm going to be at negative 1, negative 1. I've gone back 2. And then 1, 2, 3, 4, I should be at negative 2. When you get a function that has been multiplied either on the inside or the outside, the easiest way to do this is to create a t-table. Simple x and y values. Okay, compare the graphs. Well, I know what my parent function looks like. Absolute value graph makes a v. And its points are 1, 1, 2, 2, 3, 3. They're very easy. So if I make a graph and say this is h of x, my normal points would be 0, 0, 1, 1, and let's go on the other side so we know where that v is, negative 1, 1. Now, if I change that to instead of h of x, or instead of, that shouldn't say h of x, because that should be my parent graph. We'll just call that y. Now if I want to change that to 3 absolute value x, well, I take my x values, 3 times the absolute value of 0, 0. 3 times the absolute value of 1, 3. 3 times the absolute value of negative 1. It's going to be 3. So I have found the v. I'm at 0, 0. I'm at 1, 3. And I'm at negative 1, 3. Okay, I multiplied on the outside, which means a vertical change. And what happens is I stretched it vertically. So if I turn this into 1/3 absolute value x, I've got my same original points, 0, 0, 1, 1, negative 1, 1. My change, my 1/3 absolute value x. Well, 1/3 times the absolute value of 0 would be 1/3. Oh wait, would be 0. 1/3 times the absolute value of 1 would be 1/3. 1/3 times the absolute value of negative 1 would be 1/3 again. I found my v, but I really don't have any good points. So I'm going to skip down and make a 3. Well, 1/3 times the absolute value of 3 will be 1. So now I know on my graph I've got 0, 0. I've got 1 and 1/3, but I want to put that on my graph. So I'm going to go out here to 3 and mark it at 1. And that's the same thing, a negative 3 at positive 1. So now I have that graph. Again, multiplied on the outside meant a vertical change. This time it was a vertical compression. So I squeezed it in.